The Senior Design Project is partnered with Daimler Trucks North America. Faculty mentor is John Dunn, and the industry supporter is Ted Ingold. Team members are James Smith, Caitlin Crummy, Benjamin White, David Schwartz, and Omar Altum. The goal of this project is to create component-level air leak testing process to improve the overall failure rate of the vehicle air leak test. The design process must take no longer than 6 minutes testing subassemblies. Process will include automation to run their air leak test. By the end of this project, the team will deliver a prototype for proof of concept to Daimler.
The test setup consists of a dedicated air supply that will provide air at testing pressure. The air regulator will ensure that the test system does not exceed 125 psi. Once the system has reached testing pressure, solenoid valve 1 closes. The pressure decay test will begin and the pressure transducer will read the initial and final pressure. Everything within the black box is reserved for valve testing only. When both valve and tank subassembly testing has concluded, solenoid valve 2 opens to release the pressure in the system. The system is now available for testing another subassembly.
The process of this project involves human setup, but the leak test itself is automated. The operator connects the tester hose to the device and uses plugs to seal any open connections on a given component. The operator presses start and inputs the truck number and part numbers. From here, the test runs, and any leaks are fixed if detected. The reason for any failure must be input into the program before a failed test is considered complete. After a successful test, all connections and plugs can be disconnected and removed.
The Arduino Uno is the microcontroller that is used to run the test and control the solenoid valves and pressure transducer. An RS-232 Arduino shield is connected to the Arduino to allow the connection to the pressure transducer. We are using precision pressure transducer to measure air pressure during test. It is powered with 12-volt DC power supply. A 24-volt AC power supply is used to operate the solenoid valves, with relays connected to them to convert small electrical stimuli into larger currents. They can be connected to any digital pins on the Arduino.
We will be able to detect leaks using the Fluke II900, which picks up on sonic frequency. This displays a visual on the screen which intensifies depending on the size of the leak. For our future plans, we need to assemble the air leak testing system and test the setup. Code needs to be written for the test system to run. To test the system, we will need to be able to efficiently plug the open fittings and remove those plugs with ease. We have a potential design in place as well as alternatives that we are pursuing. After the system is functioning, we will need to refine the process and get a total test time below 6 minutes and integrate into Daimler's current manufacturing process.